This is an in-class assignment given on Wednesday to design 4 modules, where one module is for unsigned digital display, other module is for tools complement, other one is 2 by 1 max, and then the top module we need to instantiate these 3 modules. So I play. First module is unsigned digital display. There are 4-bit input and 10-bit output, and uh, as per the input, the display has to display the following binary digits, so we will get our numbers on the digital display. So there are 16 different cases, so you're done using the case input. Here for case 0, these are the outputs. This should be on the digital display to get 0 on the digital display. In the same way I've done for all the 16 different inputs using the case statement. So it has to be done always when there is an input. So I've used that. I've declared output as red. This is for unsigned digital display. And then I have made a complement display. Then this is for whenever the input is in 2's complement, the output has to be done as per the truth table given. So here again I'm using the case statement, and output as register and input in and the 4-bit. So there are 16 different cases I have done using the case statement. So whenever there is a 0, the following has to be displayed on the digital display. Whenever there is 8, it will give the 2's complement calculated for the given binary digit. So this is for complement display. Then after that, there is a mux. Here, the 2 outputs of the first 2 stages will come as an inputs to the 2 by 1 mux. So for this, I have given another one more signal called the selection signal. Selection signal. As per the selection signal, the mux will perform. It will select P1, P2 as per the input of the selection signal, and then I have declared a top module here. The input is in and output is D, and the another input is 2's complement, and one more is clock. Here I have declared them as a input as a 4-digit. That's what I declared here. Then the input is 2's complement. Other one is input is clock. Then I've declared the wires. Here I'm instantiating the complement display, where that input IN is the input, M2 is the output of it, and I'm instantiating unsigned digital display. IN is the input, M1 is the output, and 2 to 1 mux I'm instantiating here. M1, M2 are the inputs, and 2's complement is also input, and M3 is the output. As per the question, it has to be the output has to come when there is a positive edge of the clock. So always at the positive edge of the clock, I'm assigning M3 to the grid. This is our final output. So here I'm instantiating the uh, first three modules. Then I'm compiling all the modules. Then I was simulated. While simulation, I'm giving different loss frequencies for the 4 inputs, and that is first input is 100. Then I'm doubling for every input digit. Then I'm double the frequency of that. I'm giving the selection signal. Then I've declared the clock signal as per the requirement. So here is the output for the different combination of inputs. When then selection signal is 1 and the clock is 1, the output is this. So when there is 110, the selection signal is 0. So it is taking M3 will be the output, and the same is given to the digital output. And when there is 1011 was the input given, then the selection signal is 1. Selection signal is 1. Then the output will be as per the M1. When the given input is 1111 and selection signal is 1, the output will be M1. So here, when the 0101, then it is M1, M2 will be the same as displayed. When the given input is 1110 and the selection signal is 0, so it is taking M2. So the final output will be as same as M2. So when the selection signal is 1 and the input is 1, So the final output will be the same as input. So these are the different combinations, different 16 different combinations we have for the different outputs. When it is 1101, it has calculated, it has taken its 2's complement and the selection signal is 0. So the M3 is the same as D. So the final output is in 2's complement, that is the negative number will be displayed on the screen. And these are the different outputs. When the selection signal is 0, the same will be displayed on the screen. When the selection signal is 1, for 0, the same is displayed on the screen. So this is the final output for the given for the given question in class 3 assignment.